Hello everyone, I am Manjunath, a student for Mechanical Engineering in Government Polytechnic Hubli. My topic is Mechatronics and my topic is LVDT in this presentation guided by Kiran Alwar sir. First I will discuss about context of this presentation. First one, the introduction of LVDT, and second one, construction of LVDT, and third one, working of LVDT, and fourth one, advantages and disadvantages of LVDT, and last one, applications of LVDT. First, introduction of LVDT. The LVDT full form is Linear Variable Differential Transformer. The LVDT's main principle is mutual induction principle and also the output across the secondary coil in the form of differential voltage. And it is categorized as an inductive sensor, inductive transducer used in generally most of inductive sensor. This is example for this point. The inductive sensor are used in speed or position and the object. And now let's discuss about concept of LVDT in detail. Construction of LVDT. This is schematic diagram, two secondary coil and one primary coil and center of the iron core. This iron core is movable inside the tube. The iron core is displacement of the inside the tube can be EMF induced. Now let's discuss about construction in point wise. First point, the LVDT consists of one primary winding and two secondary mounted on the cylindrical tube. And there is a movable soft iron core placed inside the tube. Next, the displacement to be measured is attached this movable soft iron core. The LVDT placed inside the stainless steel housing because it will be provided electrostatic and electromagnetic shielding. Next, working of LVDT. The LVDT work on main principle is mutual induction principle. There are three cases. And case 1, when the core is moved towards the S1 maximum left side. You can see this diagram. When the core is moved towards the left side, when the core of LVDT moves towards secondary winding S2 will be more compared to the S2. This means the EMF induced S1 will be more than induced EMF in S2. The net differential voltage in output voltage E0 is equal to E1 minus E2 will be positive. And next, case 2, when the core is at a null position. Now you can see this diagram. When the core is at a null position, then flux linkage with the both secondary windings will be same. This means that EMF induced in both the windings will be same. The net output voltage will be 0. And next, case 3, when the core is moves towards the S2 maximum right side. Now you can see this diagram. When the core moves towards the right side, the LVDT moves towards secondary winding S2. This means the plus linkage with S2 will be more compared to the S1. The EMF induced in S2 will be more than induced in EMF S1. So net differential voltage, output voltage will be negative. So next, advantages of LVDT. Advantages of LVDT. First one, smooth and wide range of operation, and second one, and high sensitivity. And disadvantages of LVDT. Hence, an extra setup is required to protect if from stray magnetic field. Since it is an electromagnetic device, so it is also gets affected by the vibrations and temperature variation. And applications of LVDT. It is most used in industrial as well as servo mechanism, and it is also used in the industrial automation, aircraft, turbine, satellite, and hydraulic, etc. Now, how LVDT work in 3D animations? You can see this.
Explain the construction and working of LVDT. LVDT is also known as Linear Variable Differential Transducer or Transformer. It is a passive transducer which measures displacement. It consists of a primary coil wounded on a hollow cylindrical rod and is connected to the AC source. It also consists of two secondary coils having equal number of turns and is wounded on a hollow cylinder at equal distance on either side of the primary coil. The two secondary coils are connected with each other in series opposition. so that the net induced EMF of the two secondary coils becomes. We see that a movable soft iron core is placed inside a hollow cylinder. Position of this core with respect to the two secondary coils will affect the magnetic coupling between the primary and two secondary coils. Let's now understand how this LVDT works. We see that when an AC source is activated, alternating current starts flowing through the coil, due to which varying magnetic field is produced. Now, when this varying magnetic field interacts with the secondary coil, an EMF is induced in the two secondary coils. We see that initially the core is placed in such a position that equal EMF gets induced in both the coils, due to which the net EMF of the two secondary coils becomes zero. This position of the core is known as null position. Now, if we move the core towards the right, we see that the flux linking with coil S2 becomes greater than the flux linking with coil S1. As a result, the EMF induced in the coil S2 becomes greater than the EMF induced in coil S1, and the net EMF shows a negative value. Similarly, if we move the core towards the left, we see that the flux linking with coil S1 becomes greater than the flux linking with coil S2. As a result, EMF induced in coil S1 becomes greater than the EMF induced in coil S2, and the net EMF shows a positive value. Thus, LVDT uses the magnitude and polarity of the net EMF induced to measure the displacement of its core from the null position.
Thank you everyone seeing my presentation.